Alright, let's learn about probability. So first definition, sample space, a list of all the possible outcomes listed only once. That's important. Once, that's it. And it's not the number of possible outcomes, it's actually the list of all the outcomes. A tree diagram is one way to list and find all the outcomes of an event. If we flip a coin 3 times, we can get a tree diagram like we have here to the right. So on the first toss, we can either have heads or tails, and then from each of those, we have heads or tails again. And then from each of those, we have heads and tails again. So that we have 1, 2, 3, 4, 5, 6, 7, 8 total options. And that's when we list them over here, that this is our sample space. And we know we didn't miss anything because we used the tree diagram instead of just trying to list them out and trying to figure out what we're missing. What is the probability of getting exactly 2 tails? Well, you can see the ones that are circled have exactly 2 tails. The only ones are 3. So 3 out of 8, or 37.5%, or 0.375 is our probability of getting exactly 2 tails. A little bit more definitions. Event is a collection of all outcomes: rolling a die, flipping a coin. There's more than one possibility, it's all the options combined. A simple event is one possible outcome: rolling a 6 on a die, or flipping a tail, or heads for that matter. Remember what probability is. Probability is the measure of the likelihood of an event happening, long proportion with which a certain outcome is observed. And we'll take a look at that in a second. So here are the rules for the most part. 2 things. Probability of any event is less than or equal to 1 and greater than or equal to 0. It's got to be between 0 and 1, and it can be 0 and 1. And we'll get to that in a little bit. So it can't be over 1, and it can't be negative. And the sum of all the probabilities of all outcomes must equal 1. So if our sample space is E1, E2, E3, E, all these different little E's, then the probability of all of them have to add up to 1, because that's 100%. Probability model is a list of all possibilities in an event and their probabilities. So if we were rolling a die, we could get a 1, 2, 3, 4, 5, or 6, and since they're all equally likely, it's 1 out of 6 for each of those. Now if we flip 2 coins, we can make a head or a tree diagram, heads and tails, and then from there I can get heads and tails again. So I can have heads, 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 tails, tails, heads, or tails, tails. So it's out of 4 because there's 4 events in the sample space, and we want to record the number of tails. So you can either have 0 tails, 1 tail, or 2 tails. Here's our 0 tails, and there's only one way to do that, 1 out of 4. We have 2 ways we can get 1 tail, either get it second or get it first. So there's 2 out of 4, which simplifies to 1/2, and then 2 tails, there's only one way to get that, so it's 1 out of 4. Uniform probability is when every possible outcome has the same probability, like rolling a die. They all have the same probability, not like flipping a coin and looking for the number of tails, because we had a higher probability of getting 1 tail, because there's more ways to do it. What does it mean if the probability of an event is 1? It means it's a certainty. It's going to happen. It's not, we're not playing the odds, it's going to happen. As opposed to if the probability is 0, it means it's impossible. It can't happen. Ever, if the probability is 0. Excuse me. There are 2 approaches for probability. Theoretical, which is what should happen over a long period of time, and experimental, which is what really happened. So this is what should happen, this is what does happen. So what is the probability of flipping a coin and getting tails? Well, it's 1 out of 2. There's one way you can get tails. out of two options, heads or tails. So if you flip a coin, say 30 times, we would expect there to be 15 tails, 15 heads. Now, it's not quite even. We have 14 heads and 16 tails. It's close, but not quite there. We toss another 30. It's starting to get a little bit more lopsided. If we look at our proportions, 45 and 55, they should be 50. I toss 30 again. Now they're exactly, if I did 300, you can see that they're both pretty close. Are they exactly the same? Did heads turn up as many times as tails? No, but they're very, very close. They're both very close to 50%. So over long term, it's the number of times that it comes up, and that's what probability is all about. Complement of an event. We can write it with the little exponent of C, or we can write with the bar over E. Is every outcome in the sample space that is not in E. So it's everything except for what's listed. So the probability of rolling a 4, if we roll a die, is 1 out of 6. There's one way to get it, or 16.6%. The complement of rolling a 4 is if we get a 1, 2, 3, 5, or 6. And there's 5 ways to do that. So it's 5 out of 6, or 1 minus 1 out of 6, which is 1 minus the probability of getting a 4, gives us that. If we're still rolling a die and we want to know the probability we get an even, well, again, our sample space is 1, 2, 3, 4, 5, 6. Even 1, 2, 3, so 3 out of 6, which reduces down to 1/2, and we always simplify our fractions, or 0.5 or 50%. And the probability of the complement of even is really saying that it's odd, so it's the other ones. 1, 2, 3. So 3 out of 6 as well, or we could have done 1 minus 1/2, and we still get 1/2. So we're using this formula to find the complement of an event. It's just the opposite. It's 1 minus the other thing happening. So, suppose a bag of marbles contains 5 red marbles, 8 blue marbles, and 7 yellow marbles. What is the probability of red, blue, and yellow, and then the complements of those? First of all, we need to know how many marbles there are total. So 5 plus 8 plus 7 is 20. So all our probabilities are going to be out of 20, at least at first. Then we want to find the probability that it's a red. Well, there's 5 ways we can do that. Out of 20, which is 25%, if we put it as a fraction, it's 1/4. Got to keep it as a reduced fraction. Blue, well, there's 8 blue marbles out of a possible 20, so we can simplify that down to 2/5, or 40%, or, of course, the decimal. I'm not going to write each method each way each time. There are 7 yellows out of 20 marbles, so 7 out of 20 or 35%, or 0.35. 7 out of 20 is the reduced fraction. Now, to get our complements, it's 1 minus 5 out of 20, which is 15 out of 20. The complement of getting a blue marble is 1 minus the probability of getting a blue marble, which is 8 out of 20. So 1 minus 8 out of 20 is 12 out of 20, or 60%. The probability of getting a complement of yellow is 1 minus the probability of getting yellow, 7 out of 20. So we subtract to get 13 out of 20. We could also just subtract the percents from 100, because that's what 1 is as well. So here's a tree diagram. If we flip a coin, that's our first thing. Roll a die, which of course is singular for dice, and then we flip a coin again. So we have all these options. Now it's kind of hard to read, so when we make our tree diagrams, we need to make sure we spread them out. But how many options are there? Well, if we count on them, you can count 24 at the end of all of these. There was 2, then there was 12, and lastly there was 24. So 24 options is the number of outcomes. So what is the probability of not getting ahead? Well, we want to look at the ones where we only got tails, or so we already automatically cross out all of those because there's a head there, because we started with 1. Then here, you cross off the ones that have heads, and that's 6, so we have 6 that aren't crossed off, so 6 out of 24 equal to 1/4, which is 25%. Suppose we only want to count how many tails we got in the previous problem. So create a probability model. So here, we're going to ignore the die because that doesn't really count for us. So we have heads, work all that out. So, but we can count that there are 6 ones where we got 0 tails, and that's what this is. We have, and it might be easier to figure this out, 6 ways where we have 2 tails. So that's all of these that we didn't cross off. So that's 6 out of 24, or 1/4. So 1 minus 1/4 minus 1/4 has to be what's left, which will be our middle here, which is 1/2, or 2/4. And that's our basic probability for this chapter.